Hello everyone, this is Dr. Max, and in this video I'm going to talk about imbalanced data. How does it look like? What are some examples and how we can treat this issue in the real world problems. So our goal here is not to just review some easy examples and apply ordinary techniques to imbalanced data and see that it works perfectly. However, our goal is to look at the problems and the challenges that we face in solving real world problems that you see in your job or during a job interview you will be asked. So if you are just looking for some easy examples and some all good examples that you just can apply some ordinary techniques to solve the imbalanced data issue, you can just skip this video. Otherwise, we can look deeper into this problem and face what we are seeing in real world examples. With that, let's get started and see what is an imbalanced dataset. At first, let's take a look at some examples where we have imbalanced datasets in real world applications. We have fraud detection and clinical applications. In fraud detections, the data scientists are looking at millions of transactions and they try to predict 1% or below 1% of fraud occurrences among these transactions. So the data set would be extremely imbalanced in this case, and it would be very difficult to make a model on top of this data set to predict these rare fraud events. Also, we have clinical applications. As an example, a data scientist is trying to predict the heart attack event after a patient's discharge from the hospital. Looking at the population of the discharged patients, we have between 1 to 10% of heart attack events among those patients. So there also we have an imbalanced data sets. These kind of examples are showing us that in the real world scenarios, we have data sets that the events that we are trying to predict are pretty much at a low concentration. We can categorize the degree of imbalance for our data sets. The perfect case would be 50-50. We have both classes at the same size in our data set. But this is not what we are really going to get. If we have 20% to 40% of the minority class, we call it a mild imbalanced data set. We don't have that much of a problem here. However, if the concentration of the minority class falls below 20%, we have a moderate imbalanced data set, and that's where our problems are getting started. And even more, if we have 1% or below 1% concentration of the minority class, we have an extreme imbalanced data set. That is the most difficult because we have such a rare event to predict and we have our challenges there. So with that, let's get started talking about how we can treat the imbalanced data sets. What are the main ideas behind these problems to solve? Now let's talk about the methods to overcome the problem of the imbalanced data sets. There are two main ideas here: undersampling and oversampling. Undersampling means that we decrease the majority samples. On the other hand, oversampling means that we increase the minority samples. Look at this example here. We have an original data set at the center. in the original data set, we have one class shown as red and one class shown as blue. Obviously, we are seeing that we have much more samples of the red class than the blue class. So we have an imbalanced data set. We have two options here, either oversample or undersample. On the right, I'm showing the oversampling. It means that we increase the number of the blue classes so that we have equal number of red and blue classes. This dataset is not imbalanced anymore. We have oversampled the data. However, the other option is that we decrease the number of the red classes so that the number of the samples of blue and red are equal. This dataset on the left also is not a imbalanced dataset because we have reduced the number of the majority samples. So now that we have these two options, let's think more about each of them. By oversampling, we are adding more information into our data set. We have more samples of the blue class here, so we have more information injected into our data set. On the other hand, for the undersampling, we have taken away some information about the red classes. Lots of the samples are lost here. And dealing with real world problems, that's an issue because data is valuable. We are looking for data. We need more data. The more data that we have, the better model we can build based on that data set. So there is a yellow flag here for undersampling that we need always to be cautious about, and that is with undersampling we are losing data, we are losing information, and that is bad when we are making the model. So keep that in mind when you are comparing oversampling and undersampling. So most of the data scientists, because of that, prefer oversampling than undersampling. So with that in mind, here in this lecture, I'm going to talk more about oversampling. I will have another video talking about undersampling, and there are some methods that we can preserve some information while we are losing another part of the information. So tune in for more videos about undersampling, but here we are going to continue talking about oversampling, the examples and the methods to perform that.